Hi everyone, welcome to Nabla online class. In this video, I'm going to teach you how to find the determinant of a 3 by 3 matrix. And I have one question on the board to illustrate this. The question is, if matrix A is equal to 2, 3, 4, 5, 6, 7, 8, 9, 1. Find the determinant of matrix A. To find the determinant of this matrix, I'm going to use one method known as the pattern rule. And this rule was discovered independently by two great mathematicians. That is, Gottfried Wilhelm Leibniz from Germany and Seki Takakazu from Japan. They discovered this rule. So let's look at how you can use the rule to find the determinant of this 3 by 3 matrix. So I'll start by saying that det into the matrix A, and this is known as determinant of A. And to use the pattern rule, you know that 3 by 3 matrix has 3 rows and 3 columns. The rows we have 1, 2, 3, and the columns too 1, 2, 3. So you have to develop a pattern, and this is how the pattern look like. We have plus, minus, plus, minus, plus, minus, plus, minus, plus, and you can decide to use any of the rows to find your determinant. But I'm going to use the first row. And to use the first row, you have to look at this particular signs, plus, minus, plus. So meaning I'll go to the matrix and pick the first value of the matrix, that is the plus position. And the value there is what? 2. Then I'll write my 2 down. And immediately you write the 2, you try to find the minor of 2. And how are you going to find the minor of 2? You can see that I've repeated the matrix 3 times. I want to demonstrate how you can get the minor of 2 and the other minors. So now, to get the minor of 2, you come to where 2 is and delete that column. And also delete that row that 2 belongs to. Then what is left is what we call the minor. And you can see that we have 6, 7, 9, 1. So I'll write 6, 7, 9, 1. And this is now like 2 by 2 matrix, and we'll call it the minor of 2. Take note, if you are to use the second row, you will start by using minus 5, because the number there is 5. Then you try to delete the 5 row and the 5 column. Then you say you have 3, 4, 9, 1. 3, 4, 9, 1. If you want to use the third row, then now you start by this positive, and the number there is 8. So now you also start by saying 8. Then after that, you delete the 8 column and the 8 row, and you have 3, 4, 6, 7. 3, 4, 6, 7. I think you are getting what I'm doing here. So if you are using a particular row, your minor will be different from when you are using another row, but the answer will be the same throughout any of the rows when you use them. So I'm using the first row. Then I'll go to the next sign, which is minus. Then the sign here, the number here is 3. Then I will try and get the minor of 3. So here I'll delete the column of 3 and the row that 3 belongs to. And I have 5, 7, 8, 1. 5, 7, 8, 1. Plus, because the next sign is plus. Then I'll bring 4. And then find the minor of 4. So 4 is here. I will delete the column and delete the row. What I left is 5, 6, 8, 9. So I have 5, 6, 8, 9. And all this, you can now use them to find your determinant of matrix A. So let's continue. I'll have 2. Now, you now use the method that you normally use to find the determinant of 2 by 2 matrix. That is, you use the product of the leading diagonal values minus the product of the other diagonal values. So this is the one they call the leading diagonal. So 6 times 1 is 6, minus 9 times 7 is 63. Then I'll bring this value minus 3. Here, 1 times 5, 5, minus 8 times 7, 56, plus 4, open bracket, 9 times 5 is 45, minus 8 times 6, 48. I'll continue by saying that 2 into 6 minus 63 is minus 57, minus 3 into 5 minus 56, there will be minus 51, plus 4 into 45 minus 48, minus 3. So the numbers that are in the bracket, we call them the cofactors. That's cofactors. Those in the bracket, we call them the cofactors. We will now use the cofactors to multiply the numbers in front of them. So here, I'll have 2 times minus 57. And 2 times 7 is 14. I'll have 4 remainder 1. 2 times 5 is 10 plus the 1. 11. So that is minus 114. Negative times negative is plus. So let's say 3 times 1 is 3. 3 times 5 is 15, meaning that one is 153. Then 4 times minus 3 is minus 12. I'll continue. Minus 114 plus 153 is positive 39. Then 39 minus 12 is 27. And this is the determinant of the 3 by 3 matrix using the pattern rule. I've decided to use the first rule. You can also try by using the second or the third rule, but you have to be very careful when you are selecting your minor for each value. Next time, I'm going to use another method. We'll call that method the Sarus rule. And this rule too was discovered by one great mathematician from France called Pierre Frederick Sarus. And we'll call it the Sarus rule. Thank you for watching this video. And do not forget to subscribe to my YouTube channel, Nabla Mahami Online Class, for more videos. Bye-bye.